Welcome everyone, and thanks for having me again. Just to give you a little bit of background about myself, I'm originally from Florida, but now I reside in Northern Virginia. I grew up in Florida, so growing up in Florida gave me a early awareness of the space program, and having those experiences of seeing the space shuttle launch and from my front yard, and then just being inspired by so many of the astronauts like Dr. Mae Jemison, and just having that confidence from seeing all of that and experiencing all of that to pursue a degree in a STEM related field. I have my Ph.D. in chemistry, and I went on to work composites and nanocomposite systems. And so I started my career at NASA Kennedy Space Center in Florida. I spent some time at Marshall Space Flight Center in Huntsville, Alabama, and now I work at NASA headquarters in Washington, D.C. At NASA headquarters, I work in the Space Technology Mission Directorate. We mature technology that NASA will need for future missions, and we do that in partnership with industry, academia, and other government agencies like the Department of Defense and the Department of Energy. In order for us to explore here on Earth, and as well as distant planets and galaxies, we need technology. And so within Space Technology Mission Directorate, we know and we believe that technology drives exploration. And so what's very exciting coming up in less than a month is that NASA will have its first opportunity to launch Mars 2020 and our Perseverance rover. So I would like to share in this next video that you'll see that this video captures the excitement, the hard work, and the determination of the NASA team and all of our partners, and that includes each of you who inspire us to make the impossible possible.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
And if you've met anyone that works for NASA, we love being able to share all the great things we're working on with the public. We especially want to invoke excitement in the Artemis generation, and those are the future scientists and engineers that will continue the great work of scientific discovery and exploration here on Earth and in the universe. Today I will mostly be talking about Mars and Mars Perseverance, and in a few short weeks, starting on July 30th, we will have our first opportunity to launch Perseverance from Cape Canaveral Air Force Station in Florida. Joining Perseverance on a 7-month cruise to Mars are several cool technologies that are part of that mission. And I'm going to talk a little bit about those technologies. And those technologies will support investigating signs of ancient life and understanding the resources on Mars. But first, I want to talk a little bit about our strategy for human exploration of the solar system. Robots on Mars today, of course, and will inform human missions that will land there around the 2030s. We'll also use the moon as a proving ground to test technologies needed for the red planet. So the Artemis program is the next step in human exploration of our solar system. So through Artemis, we will see the first woman and the next man land on the moon. And specifically, we will land on the South Pole in 2024. And our goal is to establish sustainable presence with the help of our commercial partners, international partners, later in the decade. So part of our broader Moon to Mars exploration approach is that we will explore the moon and prepare our next giant leap in preparing a path for humans to explore Mars. So if we think about the moon, we know that the moon is a natural stepping stone to Mars. And NASA and the mission directorates, including Space Technology Mission Directorate, will work to demonstrate our new technologies and our capabilities that we're going to need to go farther into the solar system. So this is where my organization, Space Technology Mission Directorate, comes in. As I mentioned earlier, we develop and mature and demonstrate technologies so that we're ready for mission use. So on and around the moon, we plan to demonstrate things like precision landing and hazardous avoidance, in situ resource utilization technologies of how we extract and how we analyze water resources and regolith or soil on the lunar surface. And then we'll also look at several surface power technologies like fuel cells, fission power, and solar. And this will help us during to support long duration stays and really allow us to operate in the lunar night, which is very cold in this extreme environment. So that technology that we will use for the moon will prepare us for Mars. And the last thing I want to say on this chart is that with the Mars 2020 mission, we're taking instruments and we're doing demonstrations to the red planet. And those include, of course, our robots and our rovers. And they play a very important role in gathering intel ahead of human missions. So we call these landers and we call the instruments that they carry robotic precursor mission. So this is just a reminder of when the countdown to launch. It will be no earlier than July 30th, starting at 7:40 a.m. Eastern Standard Time. And we're going to leverage all of our discoveries in our past Mars missions to explore and understand the water and the habitability of Mars. And Perseverance, our new rover, will be directly seeking signs of past microbial ancient life. Like I said, the launch will take place no earlier than July 30th. I will provide more information at the end of this talk about how each of you can join the rest of the world in the countdown to the launch and how you can take part in the streaming of the actual launch. So we have a launch window, and regardless of when we launch during that window, we will be landing on the surface of Mars on February 18th, 2021 in the Jezero crater. So this crater is about 28 miles wide, and some of you may or may not know that Jezero means lake. And so our scientists believe that somewhere between 3 to 4 billion years ago, a river flowed at Jezero. And during that time, it deposited sediment packed with carbonate materials and clay. And they also believe that this ancient river delta, and it's about the size of Lake Tahoe, could have collected and preserved organic molecules and other potential signs of ancient life. The mission, once it lands, the mission will be at least 1 Mars year, which is equivalent to 2 Earth years. And the goal of picking the landing site is that the rover will land in a place where there's the highest potential of finding signs of this life. And just to compare with, you see several of our past rovers. So with Curiosity landed in the Gale crater in 2012. And the goal of Curiosity was to investigate Martian climate and geology, as well as to assess whether the selected site had the right environmental conditions for microbial life. So I want to introduce you to a picture of Perseverance. This mission that we'll be launching in a few weeks carries the most sophisticated suite of instruments that we've ever sent to Mars. It's built by our NASA Jet Propulsion Laboratory and managed by our Science Mission Directorate, along with a diverse team of bright and talented individuals who've worked endless and countless hours to make all of this happen. So some of you may have heard, and some of you may ask, well, where do we get the name Perseverance? Well, we got it from a member of our Artemis generation. Perseverance was named by a then 7th grader, Alex Mather, and he's from Burke, Virginia, and he attends Lake Braddock Secondary School. Perseverance is about 10 feet long, 9 feet wide, and 7 feet tall. And it weighs about 2,260 pounds. And it is the heaviest payload yet to visit the red planet. And that makes it about 278 pounds heavier than Curiosity. It looks very similar to Curiosity, and it's built on the success of Curiosity, and it contains many of Curiosity's heritage components. And so before I leave this slide, and this is something I want you all to put in the chat if you can, but I want to congratulate each of you who are riding along on Perseverance's journey. We had almost 11 million people send their names to be included on the rover. So if you did that, just put it in the chat that you're joining Perseverance on the ride to Mars. So the Space Technology Mission Directorate, in collaboration with the Science Mission Directorate and NASA's Human Exploration and Operations Mission Directorate, collaborated, and we matured and we've delivered 4 technologies that will be on Perseverance. And they're the Mars Entry, Descent, and Landing Instrumentation 2, or MEDLEY 2, Terrain Relative Navigation, or TRN, and these 2 will happen fairly soon after it arrives to Mars. And then we have the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE. And then we have our weather station, our Mars Environmental Dynamics Analyzer. So I want to show you in the next chart a quick video about how the spacecraft enters into the Mars atmosphere, and we call this process entry, descent, and landing. And so one of our scientists at JPL will walk you through what happens and why they chose the Jezero crater. So Jim, if we could play that video.
Entry, descent, landing is all about getting the vehicle from the top of the atmosphere down to the bottom safely. And we hit the atmosphere going 12, 13,000 miles per hour. We have to deploy a supersonic parachute. And that's all before we get down into powered flight. So we have a new system that'll take over at this point. It'll start taking images of the ground. That'll let us figure out where we are in latitude and longitude. Jezero Crater, the site we're going to with Mars 2020, was actually rejected for Curiosity because the site was considered too unsafe. And really the terrain was way too rough. But now we have the ability to land at these places that we never really could go to before. The Jezero Crater site, if you look at it from space, is pretty obviously a delta. We think that Mars was habitable about 4 billion years ago. So the question is not just where was that life, but also where could it be preserved for 4 more billion years?
The Mars 2020 mission, has several new technologies for entry, descent, and landing. We have range trigger, we have terrain relative navigation, of course, MEDLEY 2, and then we have a new suite of cameras and a microphone. And so we think about how entry, descent, the sequence happens. you have guided entry into the atmosphere, then you'll have a parachute descent, and then you'll have a powered descent, which is finally delivered by a sky crane. So if you think of a crane like we have on Earth, and this sky crane will lower the rover to a soft landing, wheels down on the surface of Mars. Very similar to how we landed Mars Science Laboratory or delivered Curiosity. So we talk a little bit more about our MEDLI, or our Mars Entry, Descent, and Landing Instrumentation 2 effort. This will be the first demonstration that will be used once we enter, as we're approaching the atmosphere of Mars. And Jim, if we can go to that next slide. So MEDLI 2 is a next generation of sensor suites. We did fly MEDLI 1 on MSL, and that collected data from the heat shield. But MEDLI 2 will allow us to collect temperature and pressure measurements in addition to heat flux on the heat shield and what we call the afterbody, or the back of the spacecraft. It will contain 28 sensors that will be used during the entry through that parachute phase that I just talked about. And then these sensors, like I said, they're positioned on both the heat shield and the back shell, and they will give us measurements that we've not ever received before. So entry, descent, and landing is the riskiest part of this mission. So during the 7 minutes of atmospheric entry, and it's what we call the 7 minutes of terror, the spacecraft will slow from about 12,500 miles per hour to just under 2. And the sensors will continuously record heat and pressure. And like I said, this is the first ever measurements that we will be able to obtain. We saw under MSL and Curiosity that we were not able to see anything that was happening real time, but we'll be able to do that with Perseverance. And in addition to the cameras and the sensor suites, we also, as I mentioned before, will have microphones to capture the sound. So like when the firing of the engines, we'll be able to hear all that. So we'll be able to hear and see what's going on as we enter and descend and land on the surface. And the next one I want to talk about on the next slide is called our terrain relative navigation. And that'll happen shortly after we get into Mars, as the spacecraft approaches Mars. The spacecraft includes cameras, and it'll take live images, and it'll compare them to existing images of the surface to determine the spacecraft's location. So the location or a nearby spot of hazard. So when we want to land safely, that means that we don't want to choose sites with high elevation. We need enough atmosphere so that we can slow down in time. And we want to avoid any steep slopes or big rocks that could damage the spacecraft. And so once a spot is selected, it is sent to the spacecraft's landing computer. And then a trajectory or a map is created, and the spacecraft targets that spot to land. And so TRN will choose the ideal spot only seconds before it lands. And you can see on the in the graphic in the center on this chart of how it targets spots, and then it pinpoints and diverts the spacecraft to land in a safe location. So some of you may say, well, what happens if TRN doesn't work? Does the spacecraft crash? No, our brilliant scientists have built up a backup system that will divert the rover to a safe area, and it's already been determined that area on the Jezero crater. Also in this picture that you're seeing, this was a flight test done in the desert, and it was actually done in Death Valley in California. Death Valley is often used as an analog site to Mars because there's similar terrain. And so the TRN team at JPL was able to do some early tests to prove this technology in Death Valley. So as I mentioned earlier, MEDLI 2 and TRN will happen fairly quickly before Perseverance even lands on the surface. So when you think about technology development and technology demonstration, we have one chance. to get this right. But there's a total of 7 instruments on the rover. I won't walk through each one of those, but the 2 I want to talk about would, in addition to MEDLI and TRN, is I also want to talk about MOXIE and META. And I would add that Mars Perseverance and the team, it's an international mission. So there are instruments from Norway, from France, and from Spain. And so I'll talk a little bit more about META and MOXIE in the next couple of slides. So if we go to the next slide. So META, 1 slide back, 2 slides back. Yeah. So META was in partnership with the National Institute for Aerospace Technology in Spain. And we call it our weather station. So it's a set of sensors, and it's going to provide important information like temperature and wind speed and direction, humidity, and like dust size and shape. And over the entire mission's lifetime, META is going to record data from all the sensors. It'll do this all on its own. It'll wake itself up each hour after recording and storing data, and it'll go to sleep independently over the other rover operations. Next, the PI for this is from Spain, and it's Jose Rodriguez Manfredi. In my opinion, this is only my opinion, right? But the most exciting technology is MOXIE, our Mars Oxygen in Situ Resource Utilization Experiment. So just like on Earth, where we use resources like fossil fuels to power our appliances in our home or fuel our transportation systems, so does celestial bodies like Moon and Mars. So MOXIE, and we know that Mars' atmosphere has about 95 to 96% carbon dioxide. So MOXIE will extract some carbon dioxide from the Martian atmosphere and produce oxygen. This technology will be used by future astronauts to burn like rocket fuel to return to Earth or breathing air. And this was the PI for this effort is Mike Heck, Dr. Mike Heck, out of the Massachusetts Institute of Technology. And the next slide just kind of shows you what MOXIE looks like. That gold box that you see that they're lowering into Perseverance is MOXIE. It's about the size of a car battery. It will be the first of its kind to generate products with local resources on another world. And this is a critical technology that we will need for future missions to Mars. So it's going to use this process called SOXY, or solid oxide electrolysis, and it will produce anywhere from 6 to 10 grams of oxygen per hour, and it will run up to 90 minutes, approximately 1 day out of every 2 months. And it'll be able to run in various conditions, day, night, even Martian dust storms. The PI has said that the goal is to have to complete 20 cycles, but they do expect that it'll exceed that. And if we talk about, well, how do we scale this up? According to Dr. Heck, a mega MOXIE won't be 200 times more massive. It won't get necessarily larger, but it would produce oxygen 200 times faster. And that's because, if we had enough power, power is going to drive all of our operations and our infrastructure on both the Moon and Mars. It could run continuously. So this full-size instrument would only need to be about the size of a washing machine, a little over a cubic meter. And so using the resources on Mars offers us, instead of bringing everything from Earth, it allows us to provide the infrastructure needed for astronauts to live and work on Mars. And one of the last exciting technologies that we will see, Jim, we can go to the next slide, will be on Mars Perseverance, is Ingenuity. Ingenuity is our robotic helicopter. It weighs about 4 pounds. And we like to compare this to, when the Wright brothers were the first to achieve powered controlled flight on our world. The the scientists and engineers that develop Ingenuity believe that this will be their first aircraft to attempt controlled flight on another world. It's powerful enough. We all know that Mars has a very thin atmosphere. So Ingenuity is powerful enough to lift off in the thin Martian atmosphere. And it will operate, it will fly up to 90 seconds once a day. And its primary mission is to scout out interesting targets and help plan for future driving routes for future rovers. And just like Alexander with Perseverance, the Artemis generation, they're like rock stars. So Ingenuity was named by Vanessa Rupani, an 11th grader, a then 11th grader from Alabama. And so we're so excited that Vanessa and Alexander came up with such great names, Perseverance and Ingenuity. And so I think we all believe and we all can feel confident that our future, that we're in great hands for our future. So everything we're doing right now that you've heard about what NASA's doing over the last several months, Launch America, Perseverance, Artemis, in partnerships with our domestic and international partners, as you saw with many of those payloads and partnerships with academia, both here and internationally. It's about learning and it's about preparing for future sustainability of humans on the moon and Mars. Perseverance and all of the other rovers that you saw on that previous chart, they've prepared and will prepare a path for humans to walk on the surface of Mars one day. So I want to leave you all with a final video, an invitation to join all of us to watch the launch of Mars 2020 and Perseverance starting on July 30th. But I also, before we get to that video, I also want to remind all of you Virginians, especially those of you that are in Richmond, that we have this effort called Spot the Station. And so every day of our lives since 2000, with Expedition 1, we've had people living and working in space. We right now have 5 astronauts representing an international community living on the International Space Station. And you can, if you're in Richmond, you can wave to them tomorrow at 1 a.m. as they fly over Richmond. So I hope that you have enjoyed this talk. We're going to provide you a lot more information. I think, Jim, we're going to put some things in the chat and you're going to send some stuff out because we're really excited about Mars Perseverance and our path to moon and our path to Mars. So I'm going to leave you with this final video.
3, 2, 1, liftoff! Okay, Dr. Tate, thanks very much. Tim, do we have any questions in the chat?
I have 2 that came up. One that came up early on was, how do they figure out during the launch, is there a need to avoid space trash during the launch? And, how do they figure out how to avoid things? Was one question.
Okay, we have a great team of engineers and scientists who plot the path based on the exact path from launch to stage separation from the rocket, from the Atlas V, to at the point where the spacecraft starts its cruise, its 7-month cruise to Mars. And they are aware of where all the debris may be. And it's a very safe and well-plotted path from a launch to Mars.
Nice. Another question we had is, what is the one-way time delay for signals between Earth and Perseverance projected to be?
That's a good question that I don't know.
I'm going to post in the chat too, but it looks like one of our NASA colleagues got back to us and said that the time delay is 5 to 10 minutes.
Thank you.
I have another question that says that I'm a high school student and I'm wondering how I can get involved in the mission, or I guess NASA in general.
Oh, that's a great question. NASA has a great internship program. We encourage internships and involvement. Well, right now in COVID, our interns are being very creative of having to do their internship at home, but there's plenty of work for them to do, and we're keeping them preoccupied. But Jim, I will send you information of how high school students and undergrad students and graduate students can get involved with NASA. We'd love to have you.
Someone else asked, that was great. I'm also going to put in the chat that the Virginia Space Grant Consortium, who the museum also works with a lot, they have some grant opportunities, so I'll put their link in there. Another question is, can you explain the sample return portion of the new Mars rover?
So part of the Mars rover will be to collect sample and to potential cache those samples and to return those. And so JPL folks and our EDL team are actually working on how would you return samples from the surface back to planet Earth. So we are going to collect those samples, we're going to cache those, and we're working to how do we get those back after they're collected. They will be stored on Perseverance.
Somebody mentioned, again, one of our NASA colleagues will be using the Deep Space Network antennas on Earth.
Thanks, that was great. And thanks to my NASA colleagues for that answer.
Okay, so Dr. Tate, is there anything you'd like to add?
No, just thank you again for this time. This was great. I really hope everyone enjoyed the talk. And if anyone has any follow-up questions, just send them over and we'll get them answered for you.
Okay, that's great. So once again, Dr. Tate, thank you so much for being here today. We really appreciate it. Thank you for joining us. So please join us next week at this time for Dr. Eric J. Hilton, who's Professor of Fisheries Science Department at Virginia Institute of Marine Science, who's going to be talking to us about what can you learn from a preserved shark. So definitely join us for that next week. You can register for next week's talk at smv.org. Thank you again for joining us today, and thanks again to our sponsors at Bon Secours. Thanks everyone for coming.